Hello everybody. In this video we want to go for a special cases, Newtonian mechanics for a special cases. But before we start, we are looking some of the special forces we have in the system. One of them is frictional force. And frictional force is always between the surface of the object and the bottom surface wants to move against it. It's happening because of the cold welding. So those rough surfaces, when they come in contact at rest, they fuse together, stick together. However, if there is no force acting on this object, then the friction doesn't react to keep the object at rest. But suppose I act a small force F, then still the object is at rest. That means there is a friction against it with equal amount, and the system is at equilibrium. I call this Fs, which is a static friction at static. If I increase F a bit more, and still the object is at rest, the frictional force must be equal to it at the opposite direction. And if I keep increasing F, it comes to the point that the object begins to move. So it's still not moving, still at rest, but beginning the move. So Fs is the maximum value. This is a position we say Fs is my mu Sn is the frictional coefficient, and N is the reaction force between the two surfaces, N, and this is Mg. And we know at this condition, F is equal to Fs max. So this is when the object wants to move, but still at rest, but beginning to move. Before that, still at rest. And Fs is mu Sn, and we know mu Sn, and N is equal to Mg. This is the equilibrium. And we could increase F when the object is start to move. This is the object. Then at the point that the object moves, those welded and those points that they are basically welded together, they breaks. Therefore, the frictional force actually drops. And this is where the point we say is a kinetic, not a static. Kinetic friction, and is a coefficient of kinetic times N. This position F doesn't need to be as big as the value that before had, and you can say F is equal to MA, for example. Sorry, F minus F kinetic is equal to MA, and F kinetic is mu Kn, and N is mg. The only difference is that here there is no acceleration, there's no movement. Here the object is in moving acceleration. It can be also a situation that it moves with a constant speed, then this is 0 and this 2 is equal. But what we come to know is that Fk is always less than S max, and mu k is less than mu s. This is the condition. If I draw this in a plot where the vertical axis is frictional force and the horizontal axis is my applied force, you can see that the friction keep increasing linearly by increasing F until a point that the frictional force becomes maximum value, and object begins to move. So this is mu Sn is Fs marks, and at this point, then the friction suddenly drops, and it becomes constant, and its value becomes kinetic mu Kn, which is less than the maximum, and remains constant. This is the maximum value. This shows the change of the frictional force for a system like two surfaces in contact. Now imagine, for example, if I have a system of trolley on a surface, and let's say there's no frictionless, yes, but there is one object resting against object A, and the both system moving by acting a force F and acceleration A, and I want to know what is this force and acceleration so this object doesn't drop. Now, if I consider the whole thing as a system, so the force that you have is N and ma plus mb times g. So your equation of motion for the object, both object A and B, is F equal to the total weight of the system, which is total mass of the system, is ma plus mb times A. And in the vertical direction, N is equal to ma plus mb times g. Now, if I consider this A, but I consider B as my system, so the system now change. Why I'm doing this? Because if I consider the both system, the both object as a system, the frictional force become internal force and it can't act on driving force or resistive force. But if I consider B as the system, then those forces acting on B is 1n A to B, which pushing B in this direction. Then you have the weight of B, and you have the friction here, F S A to B. Now NA to B pushing B as a driving force is MBA, and this has the same acceleration. Also, we know that this direction object B doesn't drop, so MBG must be equal to FSA to B. But because we want to know what is the maximum friction that B doesn't drop, and proportional to that, what is the value of F and A, we could say FSAD should be equal to its maximum value, US and A to B. This is where the object does not drop. So if I put the values here in this equation, you can see MBG is mu MBA. And if I drop this, A is G over mu S. F is G over mu. That's the first conclusion for acceleration of this system. This is G. Now, what about F? You just put this value there, and F is MA plus MB G over mu S. This is the value of the force F, allows B to maintain and remain connected to A. I could change a little bit this system more interesting. For example, if I have the surface and then the trolley move in this direction, but this time I would say I have object C here. I have object C, and object C is connected to a pulley which is resting here, and this is connected to object B. So let me just draw this again, more convenient. This is object C, and this is resting against A. This is object B. I want to know what is the frictional force between and the tension in this rope that object C also doesn't move and object B also doesn't move. So it's similar, roughly the similar example, but a bit more number of objects and this tension between the objects. So if I consider A and B and C as the system, then the force that's acting here, I want to know what is the force is MA plus MP plus MC times acceleration. Now, if I consider B, for example, as the system, so I have the object A, this is B, which is connected to through the rope to C. And now I'm considering B as my object. So the force acting on B is T, tension in the rope. Then you have MBG. You also have MB, correct? And also there is a force of friction between A and B, which is opposing the vertical movement, and that is Fs, A to B. So in this condition, I would say N, I would write this A to B. N A to B is MB A. This is the mass of the system. This is a driving force. And this force has to be equal to each other. So T plus Fs A to B should be equal to MBG. And we know that FSA to B is mu S N A to B. And if I go furthermore and I consider this is the pulley, I consider C now as the system. So this time C is my system. The force acting is mcg. You got NA to C, and then the tension. And the frictional force here, which is FSA to C. Now the equation here, when you consider C, is T, and then this frictional force is in this direction because it wants to A moves in this direction and pull C together with itself. So it has to be T plus F A to C equal MCA, and then FA to C is mu MCG, and then N A to C equal MC G. These are equations for different situations when you have different part of this as a system. And you can substitute between together to calculate the acceleration or the frictional force, and